Bryan,
Adam, how are you?
I'm doing well. How about you?
I'm doing well. Yeah, I'm excited for this episode. I gotta tell you,
Yeah, long time coming.
a long time coming. A long time
Yeah,
coming. Did you go back and listen to our episode from 2 years ago?
I did not. I take it you did.
I did, and it was great, but it was really very much about manufacturing the first rack, and that was which is like, hey, there's plenty to focus on there. And
Actually, you know what? I did. I did actually listen to this episode, but I listened to it like 2 or 3 weeks ago when we were supposed to have this episode,
yeah,
and we talked.
yeah.
We talked about
Look
the
at you.
crate, and we talked about the whole thing. It was great.
This is
No,
one
I
of those,
did.
like, wait a minute, I accidentally did the homework. I did the homework when I thought it was assigned when it wasn't, and now
Yeah.
I forgot that I did it.
Yeah, I thought it was due, but yeah, then I forgot that I did it. Exactly.
But no, it was great. But there's been a lot that has happened in the meantime. So
Yes.
I'm really happy to get everyone here. So we've got CJ here and Doug and Aaron, I think, and Kirsten and Eric, presumably en route.
Yes.
If CJ can find the mute button, I got to say CJ is.
Hey.
CJ is having some generational struggles today. Sorry, CJ, I'm going to call you out. I really, it really kills me to do this. It kills me to do this. So CJ's like, it doesn't kill you to do it because you seem to be still doing it. CJ was talking about something that we need to get done. He's like, hey, yeah, no, I owe Megan a couple of those, and I want to be at six to seven by the end of the week. And I'm like, you do not hang out with any teenagers. Like, you are nowhere. You don't live next to a teenager. You have got zero contact with teenagers. And Adam, maybe you've got. Surely, Adam.
Peripherally aware, I would say at best.
You like, if I were, and I guess CJ, I am also so trained to now avoid that in any conversation because it just derails it into brain rot memes. It is really very troubling what is happening to our youth.
I'll make it 7 to 8. It's 7 to 8 from now on.
There you go.
You know, it's sadly, like you can make it 7 to 8, and 7 to 8 is too close to 6 to just pick 7. I just like, you're gonna have to you just have to be further away. I tend to avoid any kind of numeracy. Actually, I just really
all numbers below 10 are really unsafe.
All numbers below 10 are. I just think you're playing with fire. But then also I was walked through like what became a thing and then what is in and what is out. It's just very the culture is moving too quickly. That's what I like to say.
I think we can all agree on that.
There we go. But great to have you all here. This is terrific. So, all right, let's kind of kick it off because we, in terms of like where we were when we did this 2 years ago, we really just started manufacturing the thing, and we kind of had the idea that at some point we would need to scale manufacturing. And we kind of spent like CJ, I don't think it's too much of an exaggeration to say that we really kind of have been spending the intervening time doing a bunch of things to get ahead of the need to scale. And then, in the last N months, we've kneed up and now like it's on. And I think it's fair to say that demand is outstripping supply. And we've got some exciting problems. So do you want to kind of walk us through some of the excitement there and what that's meant?
Well, certainly. I was just thinking to myself, I was like, wow, was it really only 2 years ago? But yeah, time is flying. And it's something that we've kind of always thought about in the abstract, right? Where we are today versus where we want to be eventually. And so, common supply chain things, process definition, documentation, staffing. These things all feel kind of abstract when you're dealing with the immediate, got to ship the next one, and slowly getting better along the way. I think we've done a lot of things, maybe kind of below the waterline in operations in partnership with the engineering team to kind of get to where we are today that actually put us in a pretty good position to go scale. We've got a crew of folks that have been at Oxide for, on the supply chain side, 4 years or thereabouts. And I was just thinking to myself how grateful I am that we've got this core group of folks that have been involved for several years now because we have a really good feel for the product. Everything from the bill of materials and how it's structured, how it gets built. Eric Anderson will be joining. I think he's doing a drop off for one of his kids right now, or a pickup rather. But Eric has been with us for about 4 years, and I often joke that my single greatest contribution to Oxide so far has been introducing Eric to Steve and Bryan and Kate. He sets the pace for the operations team, and he's our boots on the ground with our contract manufacturer. And Kirsten has also been here for almost 4 years, or over 4 years now. And on the procurement side, just the complexity of roughly 1,000 items on the bill of materials to go buy, in smaller volumes and now in much higher volumes. And there's been some additional complexity here recently with buying things. We source globally, so it's been exciting to think about how to get all these parts to show up on time. But yeah, I would say in general, going from shipping one and then the next one or the next two to now we're looking at 10x that volume is exciting, and I am so grateful that the folks that we have working on this at Oxide have been doing it for a while, and I feel very well placed to go pull this off.
Yeah, so let's talk a little bit, and in particular, because I think that, and maybe frequent listeners to the pod will realize this, but folks that are kind of new to hardware may not realize that Oxide, we do not have our own manufacturing facility. We use a contract manufacturer.
Right.
Do you want to just talk a little bit about why? And I think that's, I think it's probably true of virtually certainly any startup doing hardware, but most companies doing hardware use contract manufacturers. Do you want to describe a little bit about why we use contract manufacturer in terms of Benchmark Electronics?
Yeah, certainly. So we've partnered with Benchmark since the beginning. We're proud to build our product or assemble our product in Minnesota. And the advantage of contract manufacturing is, manufacturing is a very capital intensive business. Really, it comes down to a couple of things inside the four walls of Benchmark. In Rochester, it's you have the SMT side, which is taking raw circuit boards and converting them into printed circuit board assemblies. So those are automated production lines that do all the SMT things.
SMT is service mount technology.
Yeah, service mount technology. All the pick and place machines, and mesmerizing to watch for sure.
Mesmerizing to watch. Oh, so mesmerizing to watch. Even in the home, it's Nathaniel's home lab pick and place is mesmerizing to watch. Like, let alone when you actually watch like an industrial pick and place is really mesmerizing.
Yeah, but those are very capable lines that that Benchmark has, and then the other side of the house, it's assembly. And so, thinking about how do you put together the work instructions, the workstations, the staffing, the training, all of the compliance things you got to think about, safety. And so the advantage you get with a contract manufacturer is, you can partner with these firms who do nothing but this all day, every day, and take advantage of some of that investment and expertise that they have. And it's been, I think, absolutely the right decision from the get-go in terms of what we've done here at Oxide, partnering with Benchmark. Really high-end CM that we're proud to work with.
Well, and one that understands NPI, right? NPI is new product introduction, and NPI poses different problems to scaling up manufacturing. Do you want to elaborate on what some of the kind of the different challenges are at those different scales?
Oh gosh, NPI. I think back to Gimlet, and we were working close with the NPI team, and I think when you go over to the production side of the house, let me start by production side first before I talk about NPI. Production side, things need to be very, very well defined. The bill of materials needs to be largely locked. You would hopefully accomplish some like low rate initial production of the builds to kind of help dial in your processes. On the NPI side, it's very, it's much more flexible. I recall, is Robert Keith on? I think I think for the Gimlet builds, I think RFK literally went out to Benchmark with like a bag of parts and was like, "Hey, we're changing the bomb. You need to put these on there." And these parts were upwards. I mean, it was so to give you a sense of the flexibility that you can pull off an NPI. That's kind of the level that you need. Versus production where things need to be much more dialed in because you're operating at some kind of volume. And you start worrying more about getting line time, getting allocated, because we're not the only customer at Benchmark. I think in general we've punched way above our weight at Benchmark, which has been great and largely
way above our weight. Yeah,
the relationships that Eric's built over there. But yeah, I mean NPI is really key towards flexibility. You don't have a lot of documentation. You don't have a lot of things dialed in just yet. By the time you get to production, all that needs to be figured out.
And so you need that flexibility on NPI, and it's I don't know, how common is it to have NPI and production kind of from the same house? Is that certainly that was a strength of Benchmark from our perspectives, that they could do both. That they could work with us on NPI, and then we also knew that we had a real path to scale up.
Yeah, certainly in the same facility, because you'll see a lot of CMs will do like an NPI focused facility, but what Benchmark has there is they can do NPI and then volume. And so the advantage that Benchmark has is they've got a couple of facilities in the Minnesota division. We're primarily in Rochester now, but they've got another facility down the road in Winona that we've built at before. And so the ability to go from NPI to volume, whether it's the same building or just within the same division, is pretty unique and has been very, very helpful for us. So yeah, I will say, like, we tried doing NPI on the production side, and I don't think we'll do that again. We like the flexibility. It turns out we really need that flexibility before we kind of hand it over to production.
Yeah. And then, okay, so then what are some of the things that we learned in manufacturing? Because we, most of this experience is with Gimlet, but of course we're shifting our focus to Cosmo here. Gimlet being our AMD Milan-based sled, Cosmo being our AMD Turin-based sled. What are some of the things we learned with the manufacturing of Gimlet? Like I guess we talked about what worked, but of course what didn't work is always more interesting. What were some of the kind of the manufacturing things we learned about Gimlet? Some of the mishaps, some of the opportunities for improvement.
Oh gosh, I would say there were a lot of design things that we benefited from low rate initial production on.
Yeah.
I think the one that I think.
Can you elaborate on that? That's actually a very good point, actually, about benefiting from low rate production.
Yeah, I mean, because you get to tweak, anything from like the SMT stencil, right, to like optimize your SMT workflow. But I think the one that I always think of, and I know Doug is on, the cabled backplane kind of cartridges that we redesigned.
Yes.
I mean, people don't realize some of these high-speed cables. Apparently, a feature of super high-speed cables could sometimes be fragility. And so we were just going through cables like crazy, trying to put together the cable backplane. And Doug and Brooks and our mechanical engineering team redesigned the cartridges. And I'll stop talking here, Doug. I don't know if you want to chime in on what we optimized there, but what I know now is, knock on wood, we're not going through as many cables in assembly there.
Yeah, I can go through that, and Eric probably has some feedback here as well. It was certainly not a single solution here. Part of it was redesigning bits of the interface to the cable backplane to minimize stress on these cables, because for all the warning we got up front about not bending these the wrong way, they were even more fragile than we thought they would be. So going through our various early builds and finding we were replacing 2 to 3 or more of our 16 cables on every rack build, that was not a scalable method. So, in addition to making changes to the way in which they were mounted, the way in which the operators handle them, that was a small part of the overall improvement. And then our supplier interaction with our partner there, Samtech, I think proved to add a lot of value there as well, in how they're packaging them, there's been a lot of improvements there. They've been going through manufacturing process updates as well, based on feedback from us and other customers. So yeah, it's been a whole team effort to finally reduce that to zero, as it should have been from the start. But it took a bit to get there for sure, longer than I would have liked.
Yeah. Yeah. Well, I mean, Doug, that's the other thing too, is like, thank God that happened during low rate production, because I mean, getting these cables, I mean, Kirsten, what's the lead time on those? It's like 12 or 16 weeks sometimes.
Yeah, it can definitely be long.
Yeah. And so like, not great, if you were doing this at volume, that would be a much scarier scenario than I have that dialed in.
Well, I mean, yeah, it shows like, so when you damage the cables as part of, I mean, you have, I mean, there's a COGS impact, obviously, but you also, I mean, much more acute is the labor impact, the lead time impact. I mean, just like, you don't want to have to be redoing parts of it in order. Doug, as you say, it's a real impediment to scalability when you're having to put together the rack 2 or 3 times in order to get it. And then we also had the problem that it was just very hard to test the whole thing.
Yes.
Do you want to speak a little bit to kind of like what we learned about our unit of testability and the need for improvement there?
Gosh, those first few racks, they got tested at the very end, right? Which was, out of necessity. We have rack tests, and but that's a bad time to find problems. And so I would say a lot of the work over the last 18, 24 months has been in upstreaming testing and quality checks. And Aaron, we've got several testers that our mechanical and electrical engineering teams have designed, and our software team has written software for. That's really just it's been a long time coming, and we're finally getting there, and it's just so exciting to see. And I know we've had the episode before on minibar, but there's a handful of these that are going to allow us to move testing upstream, which is to say, way before it ships, so that we can find problems early, and sort of disambiguate, like, is it the sidecar, or is it the cable backplane, is it the scrimlet? Help us figure out that we've got known good units going into the rack. I don't know, Aaron, if you want to talk to any of that. I know you've been super involved.
Yeah, I was going to rewind for a second, and just think about how for those first few racks, we didn't invest in that unit level test like you had mentioned up front, and we were kind of letting the failures guide where we needed to add test. And how one of the biggest pain points, and something that still crops up, is the fact that the DDR sockets that we use are press fit.
Yeah, I was gonna say. We got to talk about the press fit connectors.
Yeah, and it's like when you're trying to press fit 16 connectors that have 288 pins, there's a pretty substantial force involved there, and not much margin for error. And it's a surprisingly manual operation at very low volume. And that was actually one of the first tests that we developed, was a kind of an early screen for DRAM, and did we press all of those pins in, and did nothing get bent over and short out, and things like that, because it's very tough to actually see that. And that's something we're looking forward to, a whole new class of problems with Cosmo and DDR5 being surface mount. But yeah,
it was definitely a problem. And because early on it was not uncommon to have DIMM fallout where you would have, 1 or 2 of the DIMMs that you couldn't actually speak to, and so getting on that and understanding kind of what was going on with the press fit. Aaron, do you recall that I had one of these where the press fit connector came off in my hand? And I got accused by everyone of ripping it off. I'm like, I don't have the physical strength to rip this thing off. Actually, trust me, it's not. But it was, and I still actually, I still have it on my desk. One of the press fit connectors that showed the 2 of the pins were just bent. I mean, that they, because a press fit connector is super violent. I mean, you are basically, Adam, it does remind me of Adam Leventhal, manufacturing engineer. This thing definitely requires a running start. It is basically like, we are just going to absolutely pound this thing in.
I mean, the directions are right there in the name, right?
Totally.
Not more complicated than that.
Right, exactly. Like press fit, it really is not more complicated than that. Like, don't overthink it. But it was definitely, and also we also had problems on pin issues with the socket. Am I remembering that correctly? Didn't we?
That was like a whole science project to figure out, because we messed with the tooling, like adapter to put the sockets in. I mean, we worked on that for a while, just to get the right amount of force distribution across the entire socket to get it into the board and trying to minimize some of these bent pins.
Hey, Eric, am I remembering correctly that we discovered that there was a height issue with one of the operators? And we realized that we need, I can't.
When you say a height issue with one of the operators, I'm sorry, does that mean
me?
one of the people building the thing was short or too tall?
Too tall.
Okay.
Eric's 6'8", so.
Yeah, I was like, if it's Eric, I know it's not too short.
That's right. Everyone's, yeah.
I think we're touching on something. So the common denominator here with, the sidecar backplane, sidecar cable, or cable backplane, sidecar cables, press fit, is that, I mean, as you scale, things you need to be looking out for. It's quite obvious, I think, potentially, but you need to make things that are processes that are be independent of the operator. So you have processes that are robust enough where they will survive beyond impact. So when we're in low rate production, we have a chance to maybe create ad hoc processes like Aaron talked about, or tests. But as you scale, that's something that is really not an option. Or you make the decision of, all right, this is a design that is not good enough, but we can live with for a certain amount of time before we can phase in a certain design change or a test. Or we make the decision to stop, and that is also very impactful as you try to consolidate to meet customer deliveries. So we've been very fortunate to be able to have that flexibility. But as we look forward, as we need to scale, those are things that we need to be very intentional about. When do we phase things in? You can't drop everything most immediately, because then you are causing mass chaos as well. So you have to be intentional about triaging what fixes are most important and incorporating those in the manufacturing line. Because everything, once we cut an engineering change order or an ECO, it's done in our hands, right? Say we pushed it, but we need to be very aware of the latency, if you will, to get something implemented on the line. So we push an ECO, well, there's training, there's work instructions and things that need to be updated. So you almost need to back plan, just like you're buying material.
Right,
but
long lead time part.
Absolutely. So those are all things that we're considering.
Well, and then I think also, this is where people will encounter the acronym DFM, Design for Manufacturing, where you realize, like, okay, this design works, but actually we could change the design and make this more readily manufacturable. And I feel we had a couple. Certainly, there was points of education on, again, what I for sure think the press fit connectors were. I think we had all kind of like, all right, we've done our experiment with the press fit connectors, and I think we're looking forward to, Aaron, I like the way you phrase it, looking forward to new problems with SMT, because that was definitely a challenge. What were some of the I mean, could we, because I don't know that have we not spoken about Medusa here, Aaron? I'm not sure. I feel like we have.
Probably not.
Yeah. Okay. So like, there's no time to ring, I think, on this one. Can you describe Medusa and why we? Because I think people don't necessarily appreciate the degree to which scaling manufacturing is this kind of all-encompassing technical problem that has operational components, process components, but also a lot of like engineering components, where it's like, okay, if we could actually build a new kind of thing here, we can actually help ourselves out. And we've done that a couple of times, certainly with Medusa. Do you want to talk a little bit about what Medusa is?
Yeah. I mean, so in the spirit of press fit is hard, we have our front plane to our networking switch is 32 QSFP ports, and each of those is also press fit in. And we were seeing similar rates of fallout. When our unit of test was like an assembled switch that we would combine or put into kind of a full loopback configuration and run all the interfaces at speed, and then you find out something is wrong and you have to spend 2 hours tearing it back down to get at the thing you need to fix. And it's all very, I mean, like we touched on already, these high performance cables are very ginger. The just minimizing touch there, both on the assembly and disassembly and rework, is critical. So we came up with this Medusa, which kind of takes our front plane board and can loop back the high-speed signals back to modules and the higher performance modules that have some of them have some self-diagnostic capabilities where they can generate and check a pattern. So we use the Medusa to loop them back. We also double check all of the slow speed signals that are actually pins that get press fit into the board and make sure that, every, whatever it is, six signals per cage actually is fully mated and making electrical contact. Because we did have a problem where our holes on some earlier revs were too big, and you could just, Brian Cantrell Hulk strength, one of these out extremely easily. So it's just in the spirit of being able to keep pushing test upstream and test at as earliest and as cheaply as possible, both time-wise and dollars-wise. So the farther you get into the process, the more confidence you have you're working with good material.
Yeah, God, I feel I've learned obviously so much in all this. Man, QSFP connectors are so complicated. I mean, I feel it's like they are their own like tiny compute sled that we are kind of press fitting in. I mean, there's just like this, they draw a lot of power. There is a lot of software complexity in them. There's just a lot to get. It's just easy to get that wrong. And being able to test that as early as possible is helpful. And Medusa is a board that allows us to do that quickly, allows us to test that but before we get the whole thing assembled.
Right. Yeah, and it's amazing the amount of functionality you can fit into a 256 byte memory map when you can just keep infinitely adding pages and banks of pages, and you're 3 dimensions removed from whatever you have paged in at any given time.
Totally. I just had a remarkable amount of complexity. And I think that like also that front IO board on Sidecar, and that is a wildly complicated board that I think we sometimes, I'm sure Aaron, you believe that we certainly don't give it its due, because you spent a lot of time on that board. That is a complicated board, and there's a lot that can go wrong there.
Yeah. Yeah. It's complicated in a really interesting way compared to like one of our compute sleds, in that it actually is kind of like the same design for the most part, copy pasted a whole bunch, because it's a bunch of cages that we have individual control over and all these things. But it's all the same thing that's going on. So it's very important to get the couple of things that it is doing right. And then whereas on the sleds, there's just like the problem is just fractal. Like there's so many various problems. And not that it's not as important to get it right, but it's much more difficult, I think, to keep them in your head. So I don't want to make it seem like that front board was too all that heroic. And that was something that RFK had done a lot on, and I just kind of helped him get over the line.
And then so it describes some of the other boards we've used to test it. So we also have a board that I learned about for the first time that we did apparently like 2 years ago, Reverso, which I'm like, I actually, there was a bit where I'm like, is that an actual board? So could you describe Reverso a little bit? And I think, Adam, you're learning about Reverso for the first time, you mentioned.
Yes.
Yeah. Yeah. So Reverso was something that actually Tom and RFK, I think we had brought this up kind of off the cuff in a meeting. And all of a sudden, like some number of months later, these boards showed up, and we didn't take the time to fully put into use. But now they're kind of becoming it's a necessity. So what it is it's just a backplane loopback. So rather than needing to put a sled into one of our cubbies, you can just put in a Reverso, and it's called a Reverso because it just connects a sidecar to another sidecar kind of directly.
Oh, so it connects like the two mega connectors, like all
right.
The networks just get connected from one to the other.
Exactly.
Wow,
so
cool.
it's really confusing to Sidecar at first before we started rolling out like the extra software here because when you use
You're
things like
I
Pilot,
see things I shouldn't be able to see.
right? Like when you're listing hosts, and it's like, well, the Sidecar in Covey 17 says, and you're just like, wait.
Wait, and are we also like wiring up ignition to ignition? Because I imagine that could be confusing as well. Okay, ignition
Right.
being the low level kind of power control.
Yeah, so none of this expects to happen. So it is some
Right.
custom software work kind of on all three networks. But what this gets us is a pretty lightweight way to test backplane connectivity. So basically we can kind of decouple our ability to assemble racks from our ability to assemble sleds.
Oh, that's really neat. And is it mechanically, does it look like a sled? Is it look just like the world's simplest sled? So you just slide it in?
It looks like a sled, and there's like, a 1/3 size PCB at the back with these connectors on it. And
Neat.
that's it. And that's part of the reason.
Cool.
So it's a lot cheaper, and these connectors do wear.
These sleds are too expensive. I'll get you a much cheaper sled, sir.
Right.
Yeah, Brian, this might be too insider baseball, but I mean, I don't know, Eric, if you want to talk about flight test gimlets that we were using before, which definitely is not going to scale. We have this pool of like walking wounded gimlets that we're not shipping for whatever reason. And so the way we were testing out racks and the cable backplane before is we would take these, and I think we're still doing this today. We take these walking wounded gimlets, which we've taken out of process and labeled as flight test gimlets, and that's what we put those in the rack to check out the backplane.
They've been designated reversos.
That's right. Super reversos, very expensive reversos. But yeah, that's definitely not going to scale. So,
and what smarts need to be on the reverso board other than the connector? So is it just inert?
It is. Yeah, it's a passive board right now.
It's a passive board. Yeah. So there's no SP on there or anything.
Nope.
And so actually, the software work to support reverso is for the software elsewhere in the rack not to lose its mind when it starts seeing things that it shouldn't see.
Yeah, exactly.
Yeah, that's really cool.
And I'd equate it like it's kind of like our fiber loop back. Like I said, it's passive. We're just ensuring connectivity, albeit that's at speed. But essentially, we're making sure there's nothing broken before we go on to the next higher level assembly when we can actually test at speed with a sled.
Totally.
So it's extremely meaningful.
So this is kind of the backplane equivalent of minibar. This is a minibar allows us to test a compute sled without needing the cable backplane. Reverso allows us to test the cable backplane without needing a compute sled. Or at least test the copies.
Yeah, that's right.
Yep.
That's very cool. And then what is the so the sidecar loopback? Describe that a little bit.
Yeah, so the sidecar loopback is that what comes after Medusa, and that is we have a full sidecar chassis, so it's all cabled together and all closed up in sheet metal, and we loop back the backplane connectors to themselves, and also the front plane with DACs, and basically run everything at speed and make sure that all of the interfaces can link up and don't have any errors. And when we find errors, then we can correlate that to ports that are failure and more specific components. So basically, that gives us the confidence that a sidecar that we put on the shelf is functional, and one of the 40 cables inside it isn't misconfigured or damaged and things like that, or a capacitor didn't get knocked off and all that fun stuff.
Right. That's cool. So this is all to serve. This is all like engineering work we've done. This is mechanical engineering in some cases. It's electrical engineering in some cases. It's industrial engineering, Eric, in terms of like process engineering in some cases. But these are all to serve getting us to get as close to a failure as possible. We don't want to discover a failure when we get the whole rack together. We want to only discover those failures that we could not have discovered earlier in the process.
Yeah, that's right. It's a much better time to find it than where 36 hours from trying to put this in a crate and ship it.
Totally. So, okay. So that is all very helpful for just getting us to be able to manufacture this thing more reliably. And we, CJ, I think you said that we kind of benefited from a slower ramp, which I definitely appreciated. Adam, I feel like that's what we did not get at Fishworks, where we, as I tell people, like, we did too much business in our first year, and because there are a whole bunch of these kinds of problems that we only discovered after we had way too many units in the field. And you just don't need, like, you don't need that many customers to hit the problem. You actually, there's a point where it's like, well, this excess customer pain was just needless.
Yeah, it's interesting, Brian. I hadn't thought about that lens of, like, being inside of a large company, starting a new product is a blessing and a curse in that regard, right? Being a startup, having a few customers, that's terrific. And if you're at a big company rolling out something new, having a few customers is impossible, right? Like, as soon as it's out there, and it's very hard to, like, hold back the floodgates.
Yeah, totally. And I think, and CJ, obviously with your experience coming from Apple, like, you are coming from that, big company world where, like, we put this thing out there and there's going to be just explosive demand. And boy, is that, that's a harder problem. And that's a problem that is, like, we will increasingly have as we get more and more mature. But we kind of, there's a kind of a fortunate blessing. And people are like, God, you guys are a startup. Like, I don't know if I want to buy 100 of them. It's like, well, don't worry. Like, we're a startup, so we're not sure we can actually, like, we might have that issue making that many, but that was, increasingly, like, that's not where we are. And we're like, no, we can, like, let's go. We're ready to take your order. But that's only because we had that slow ramp where we were able to get that stuff figured out.
Yeah, I think allowed us to lay that really solid foundation, right, for where we need to go, because we've had the time, and then importantly seen enough cycles to where we really knew where to focus our energy to kind of get these things in place. It's, like I said, it's been a long time coming. I know everyone on this call from Oxide has been talking about this for a year, and we're finally getting to the point where it's coming to fruition, which is fantastic.
Yeah, it's fun. Okay, so let's talk about another really challenging thing when it comes to, like, okay, so you got, like, the actual, like, you need to be able to physically make these things. You got to be able to physically make them in order to be able to scale that up. Like, that's got to be reliable. You just need some maturity there. You need to have it really, and we obviously we've said before that we can kind of control all of our own manufacturing software, which really helps. But you need to actually, like, have the parts. You got to go procure the parts. You got to go buy the parts. And procurement is its own total science. it is not easy. I would say, like, art and science, because I think that. Oh yeah. Kirsten, watching you, I feel like there is this, and getting into larger volumes has been, again, both a blessing and a curse. Do you want to describe some of the kind of the challenges there and opportunities?
Yeah, definitely. I've been here for 4.5 years, so I was here when we were buying parts for Gimlet EVT. So, cut strips of 100 resistors and capacitors. And now we're talking buying hundreds of thousands. So it's quite a difference. It's a much different process. It is a blessing and a curse. A lot of prayers, and it's a lot of relationships too. So, we've got about 1,000 or so parts across all of our bill of materials. So we've got the 2 main boards, or actually 3 now that we're bringing on Cosmo, and that has actually a good number of new parts on it. And then all of the smaller boards as well. So keeping everything in check, making sure that I am not the one that's holding up something from being built is my main goal every day. The good news is we do have design stability, at least on a Gimlet and pretty much the sidecar bomb. So those are little, I'm not gonna say easier to procure. You never know when you're going to find an out of stock or a part goes end of life, and there's just no supply anywhere. But when you're looking at ways to kind of, like, we have a really small team, the ops team at Oxide, so trying to optimize the number of people we have and all that we have to do, looking at our contract manufacturer to kind of help with the procurement activities is one of the things, on the table. they've got a team of people that does procurement. They do this for other customers. So really looking at those stable bombs, looking at the parts that we could easily hand over, more of the off-the-shelf parts, kind of keeping anything custom for now. There are still some tweaks being made to some things here and there. Some of them are a lot harder to procure. We've got what we call the arts and crafts parts, which I honestly have been cutting at home for quite some time now. I do finally have a supplier for them. But it's some of this stuff is just challenging. When you're talking EMI gasketing with 20-week lead times and finding someone who will cut you 500 of them, and their minimum order quantity is like 5,000. You're like, I just don't need 5,000 of them. I'll cut 500 on my kitchen table. So those are still some of the design or some of the issues with procurement. But as we scale, we're able to find suppliers now to do some of that stuff. But I think one of the biggest things, especially right now, as we're looking to scale, is the relationships with our suppliers and distributors. So
Yeah. Elaborate on that.
Yeah. So while we're looking at handing over some of the more off-the-shelf parts, keeping those relationships with the DRAM, SSD, CPU suppliers to be able to negotiate those prices and really bring them on board to sell them on Oxide. Like our suppliers, they love Oxide, they love our vision. They petition for us within their companies to get us supply. With all of the AI boom right now, it's not the easiest to get supply, especially on DRAM. We
Totally.
are not a big AI company. So having people go to bat for us with the suppliers has been a blessing. We would not have been able to do this without those relationships.
So I think that this is a really important point, Kirsten, because, and this is something we've talked about in the past, but I think that this is a really important difference about the way, I've spoken bluntly about this, that when that Joyent was bought by Samsung, and we assumed like, oh, great, this is going to be like, we're going to have Samsung's purchasing power. And this means that we're going to have newfound relationships with our suppliers. And we did have a newfound relationship with our suppliers. Our suppliers hated our guts. And we're like, what? And they're like, look, we love you at Joyent, and we're going to continue to give you the kind of support that you've had. But you should just know that, like, I'm doing this over what my executives want me to do because they hate Samsung. And I'm like, why do they hate Samsung? Doesn't Samsung like buy a lot of parts? Aren't they a huge customer? It's like, yeah, but Samsung wants to dual source absolutely everything all the time. They're constantly pitting their suppliers against one another. And the thing that was kind of the aha moment is like, you think that like, oh, that makes sense. Like dual source everything. Like that's the way to get the best thing, is to have everybody fight all the time. And it's like, no, everybody hates your guts. And what it means is that if you need anything, nobody cares because you've shown that you don't care about the relationship. So they don't care about the relationship. And, Kirsten, it was really interesting to have you come aboard. You're coming from Lenovo. And, CJ, I know that you had this suspicion too, coming from Apple, because I kind of assumed that like, oh, well, these folks are coming from, other companies and then maybe like this is just a Samsung thing. But you're like, no, I love the fact that I can actually build a relationship here, because when you are constantly pitting suppliers against one another, one, you're saying like, I don't actually care about your differentiator. And we've always said like, no, we want to pick the right part and then really go deep with you. And then like, yeah, we do expect that you're going to give us competitive pricing, but you should know that like, we're all in on you. So you're giving us competitive pricing because you want us to succeed as a business, and not because like, I don't need to threaten you to do that. And in fact, we think that it's much more. And so it's always interesting to me when hearing when you're, just boots on ground describe, and I feel we've seen that like over and over and over and over again. And the magic that you all were able to pull off during the supply crunch. And then, as you say, like with the AI boom and us needing to fight for parts, it's really important to have those relationships.
Yeah, it definitely is. And one of the things that I communicate with my suppliers, and we've got really great relationships. I would say we're friends outside of just the work atmosphere. is that I don't have the time nor the desire to sit there and negotiate back and forth. Like, I just expect you, give me your best price first go around. I'm not going to go past your price to somebody else. I don't play that game. And I know that
Right.
maybe some other companies do, is let's trust each other and let's have an actual like working relationship, open, transparency. It's not one of my favorite words, but it's true. Is I don't have the time to haggle back and forth. I like you guys. I want to use you. We love your product. You give us great support. Let's just give us a price.
Yeah.
And that's different. We still have some vendors that'll come back with a form to fill out, and they're like, well, "Who's the competitor? Who are we going up against? What's their price? What's your target price?" I'm like, "My target price is 0. Like, I'd love it for free." But
right.
Yeah, I think the relationships we have been great to date. It's been really great working with our suppliers, and they really are Oxide fans, which is nice. And I think we are probably a bit of fresh air for them as well. Not being
Totally. Yes.
one of those other companies.
Yeah, and I just think that like they are relieved, like, oh my God, like you actually want to build a relationship with us. And then I think that, and I think we talked about this in the past, but you pulled off a miracle with Sanyo Denki when they had a supply chain issue. They let you get into their BOM, figure out the part that they were actually corked on, which, if I recall correctly, was a TI FET, because it was like, it's always a TI FET at the end of the day. I feel like
it was. I remember this.
And you then like, look, I can go find that FET elsewhere and broker it to you, but I need you to support it under warranty. And Kirsten, if I'm remembering that story correctly, they're like, yeah, we're willing to do that. We have never done that before. Like, this is we have never even contemplated that before, but they were willing to do it for us. And that was clutch.
I know. Yeah, I know. Well, we had issues with Sanyo Denki and Murata. And I know that I think it might have been Murata that we ended up getting finally a list of like 28 parts that they couldn't find. And I just kept finding them and sending them to them. And some we had to buy, some they could buy. And I was like, listen, and they're like, well, I have to buy like 1,000. We only needed like 200. I'm like, use them for your other customers, but just make sure they know where they came from.
Nice.
So we were helping out their other customers too, because
totally, yeah.
Yeah.
Well, that is so collaborative. I mean, I think obviously you win you build a relationship with, when you're like, God, you're solving this other problem I've got another customer that's breathing down my neck, and now you're able to, that is just extraordinary. And really, I mean, again, speaks of the relationship. The other thing is, like, I think it's really important is the relationship between procurement and engineering, because I think one of the people ask us, like, how do you like this, like, power observability that you have in the machine? Why don't I have that everywhere? And it's like, well, because you get these part swaps that happen, and the different organizations aren't connected. And people are like, well, that's like, this other part is like a little bit cheaper and easier to get, and it looks like it's the same, so I'm going to swap it in. And I think that I love the collaboration that we've got between engineering and procurement, which sometimes means that, CJ, I do recall you asking once about the TPS 546B 24A, the beloved DC converter. I love this part, Adam. Have you looked at this part at all?
No.
Okay, this is a TI regulator that is just like this thing is a little champ. It's got like a 1,200 page data sheet. I may be exaggerating, but not by much.
Don't let the other regulators know that you feel this way, though.
I want actually, I want to hold this up. I want the other regulators to see it. I'm going to hold hands with this regulator in public. No, we're Facebook
going steady.
Public. Good. Or whatever. Exactly. We're going steady. We're going steady.
Yeah.
This is a little regulator that does its job. We use it everywhere. It's got really rich PM bus support, which is the reason that data sheet is so long, because like the PM bus support is good. It's a part that we really trust. And so at some point, CJ was like, these are really hard to get. How about this other one? And CJ, I can't even remember what that suggestion did not last very long. I feel it was like, I kind of had to dig you out of the bottom of a dog pile that maybe I was on terms of the, you're like, okay, I get it. Like, everybody loves this regulator. I will just go, fine. I'll just go make some. I don't know. I'll go find some.
Kirsten probably found it. Yeah.
And
the only thing I would add is like, Kirsten's done an amazing job. Again, kind of back to the low rate production to ramp, it's really hard to build like the relationship you need when you're ramping while you're ramping. And so very grateful for all the work that Kirsten's done in procurement with building these relationships. Eric also does a fair bit of procurement work with sheet metal and circuit board suppliers that have come in very, very handy in our moment of need here. Just, how we started, how, like, not just what we're doing, but how we're doing it, I think is really paying dividends for us now. Really, really great job for those folks.
Totally. Also, I got to think, and Kirsten, I'm sure you have felt this too. Eric, I know you felt this, CJ, in terms of like, we have these advocates at these partners and we really appreciate them, but like, we're also like little and weird. And for us to like really have explosive growth, it just feels good to like go back to them and be like, oh my gosh, like you guys are actually going to make it. I don't know. I think it's really fun. Very satisfying all around.
Yeah, it has been very satisfying. They're very excited for it. Yeah, it's been a fun job.
That is awesome. That is awesome. And so, the one question is that there are a bunch of disadvantages to being low volume, but there's some advantages too, in that like we're just not looking for as many parts, and we can, when we get to higher volume, Kirsten, what have been some of your the challenges at those higher volumes? Because the numbers get really big. I also got to say, you all have got guts, because like you got to like lock in a price. And these are not small purchase orders. These are like kind of stomach churning purchase orders. And you got to be like, nope, like we go now. Like, I know that this price is only going up. I know this is the best price. We've got to commit. I mean, I just really admire that, like, it's knowing hard when you got a good price. Yeah, totally.
I mean, I put a PO together. It was the largest PO I ever put together. And I sat on it for about an hour after I did it. Cause I'm like, I can't send this yet. Like, I'm sending this to Steve and asking to sign a lot of money away. Yeah, I mean, growth is great, but when you're all of a sudden looking for like 100, 200, 900,000 of this one part number, it does get a little challenging to go find all that on a whim. We're also, as we scale and demand increases, there were parts that we looked at back in 2022, 2023. We knew they were going end of life. We thought we had enough, right? Until we got to a board spin, and they're just popping up in the last couple of weeks that that supply that we bought extra of in 2023 to take us all the way through 2026, we're going to run out of in a couple months. And that went end of life 3 years ago. So thanks to the engineering team, a couple of you are on this call, they've gotten a lot of requests in GitHub in the last week or so to go, we have to find drop-in replacements, because we've got Cosmo boards, out at the manufacturer right now, about to start building. So there's definitely been some pains along with it.
Aaron, are we looking at the ADM 1272 when is that what this is all? Is that what this is about?
It's still fighting. It's not still that fighting.
Okay, good. Because we've had some of these things have been surprise EOLs a little bit, where we've had some EOLs have gone, and I know with the 1272, apparently that's we're hoping to get that thing's banging on the coffin lid. I think hopefully we're going to get a revival there. It's another regulator that I'm less fond of, Adam. I will have.
Yeah, we had another one come up that was one of the LEDs. So, we've got 8,000 in stock, but we need more. And it's like you don't want to change an LED like mid production. They all need to look alike. So just some small things like that. We'll get through it. But yeah, I mean, good growing pains, but just some things are popping up that maybe weren't on the horizon right now.
Well, and I just think, and as Eric is saying in the chat, there's a lot of kind of natural empathy from engineering for operations. And I just think it's been very collaborative. Like when you've had one of these problems, Kirsten, it's like, okay, well, let's go brainstorm, what can we find? What are some alternatives here? How can we, put some things on we just don't view it as, we want to get creative about how we can solve these problems. But I just feel like there's new problems every day.
There are, yeah. But one of the other good things that we've done is, we probably did this actually a couple of years ago, is, when the engineers are adding a new part or changing a part, that I get notified right before the ECO goes out, so I can make sure that I've, hey guys, there's like no supplies available, or okay, this is fine, I approve it, and then I can go procure ahead of time to make sure that we have the supply when that ECO rolls out. So there's been some really good collaboration and just some changes to the process to improve things all around over the past couple of years.
Yeah.
That's part of like the engineering culture to try to build to, is you can't just pick whatever you want and design it in. It also has to be procurable at whatever scale that thing needs to be built at. And sometimes like the ability to mark something as problematic for procurement in, whatever database, part database we're using is really critical.
Yeah. And we also, I mean, it's also helped as we have like now we've got experience with these various parts, and it is helpful to like, if we can use some of our existing, I mean, this is what we kind of talked about earlier in terms of design stability. We're not going to just change things for the purpose of changing them. If we've got a part that we know works, we've got a regulator that we like or a service processor that we like, we're going to really weigh any change there very seriously. And certainly procurement is going to be part of that calculus.
But Bryan, the other thing that we're not really talking about, maybe we shouldn't talk about, but I'll just say it, is heroic effort by Kirsten, because we're doing this. We have some tooling, but it's a lot of spreadsheets, right?
Totally.
It is like, Eric and I talk about this all the time. It's not going to be CPUs that stops us in our tracks, right? It's going to be a nylon threaded fastener or something. And so, we're in Twitch Town, trying to just double check, triple check the entire bill of materials and make sure we have coverage. And Kirsten lives this every day of just making sure that everything that we need to order is on order and getting delivered on time. And it's a ton of manual effort. And so we're certainly looking to make investments there to lighten that load, but it's very startup-y, I would say, in terms of how we've been kind of planning all this to date. And again, amazed that we're as well positioned as we are to go scale, but plenty of work to do on that front to help Kirsten out with some of the, what you need to focus on today and how much and how many, those kinds of things.
Totally. And of course, like the kind of the body of software that you're referring to, but not naming is ERP.
Yes.
And I think, a startup would be kind of foolish to do a big, complicated ERP build out before they have product market fit. And then you're kind of like, I mean, you can only deploy an ERP system like too early or too late, I guess. So
I mean, look, for all its flaws, like if Kirsten needed to order a part right now, she could cut a PO in 2 minutes. And so Can you do that in an ERP? It's not always so easy. So yeah, I think, it's served us well, but it's time to make some investments there, and we will. But yeah, just heroic levels of attention to detail and I don't know, a small dose of paranoia, I think, to make sure that we've got all this covered down on. So
totally, yeah. ERP is enterprise resource planning, and this is kind of software that is, I would say, infamous in terms of asking businesses to change for the software is kind of my perception, CJ, of ERP. Where you have, this is very enterprisey software. I mean, I guess it says it right there in the tin. I guess you should really be like any enterprise software that has enterprise in its name, is like extra enterprise software. But these are companies like SAP. And, I think that we also want to be kind of careful about how we move into that. Certainly with PLM software, our disposition has been like you need so much customization. And, I do think that like we're in a world where it's a lot easier to write one's own software. And I'm not saying we're going to write our own ERP, but, I guess, yeah.
Thank God.
But you're thinking it.
Yeah. I'll let someone else say it.
Yeah, no, you're absolutely right. I mean, the good news is Todd Weldy on our team is an ERP expert and has used them all. And just like Oxide does with everything else, there'll be an RFD, with the things that we care about, and we'll be careful about the selection process. But
and the conversion. And so Tom Lyon is in the chat making reference to something that was a that was recent when, I mean, it actually wasn't recent. It was in 1989, I think, Tom, right? But no, when I arrived in 96, like this was still like legendary. So there was an ERP deployment at Sun that broke Sun, and they couldn't ship. And this is like when ERP deployments go wrong, it's like customers are, I mean, it is bad.
This was like they had no visibility into the quarter, like didn't know how much business had been booked, couldn't book new business. It was a disaster at Wall Street, right?
It's a disaster. It's a disaster. And like, and obviously like, it's not, there are like lots of blame on that one. That's not the software didn't make the decision to deploy itself poorly.
You know, what's hard to find is a story of an ERP implementation that went well. It's actually
interesting.
It's all nightmare stories. So yeah, we'll certainly be very careful. But
yeah, and and we'll be, you know, and we will presumably also like take advantage of the fact that we do have like different muscle at Oxide than other companies might have in terms of like, there are certain software problems that we're just not afraid of, and not that we would, we just are going to be, you know, we're going to go into it, I think, with maybe a different perspective. But interesting. Yeah, Adam, the ERP thing is in High Noon. I think, yeah, because it was definitely infamous.
Yeah. I'm pretty sure it was. I read about it in High Noon, but I can't check because I gave you my copy.
You know, and I did not regift it. I would like you to know. This is why I don't give away my books. You know, I don't mean to punish you for having given your book to me. I feel that this was, although, you know, I say that with an asterisk because I gave my copy of Hypergrowth. My copy of Hypergrowth has definitely gone around like the clap at Oxide. PJ,
the clap has not gone around at Oxide. I just want to just for the record.
That's kind of, I guess that's oh, there we go. Yeah, Steve's in the chat, knowing where the copy of Hypergrowth has stopped. It has not made. Hey, did you read Hypergrowth, Adam? It is really.
No, I haven't read it.
So
I'm waiting for Steve to finish with it. No, I'm just kidding.
I know we all are. Let's hope we don't go out of business because of an operational mishap. Well, Steve. Well, the thing is that is interesting, and obviously with Hypergrowth, you are very much getting like the one perspective of, and you're getting Adam Osborne's perspective. But there are companies that get into a lot of trouble, and I guess we talked about it with Sun in this ERP transition because of operational mishaps. Like operational mishaps, I would say it is less likely to damage a company than not having product market fit, which I think is overwhelmingly. I mean, Adam, feel free to disagree, but it
feels like yeah. I mean, no matter how operationally savvy you are, like having the wrong product in the wrong market seems like an impediment.
It seems like an impediment. But there are counterexamples where companies have product market fit and then they make operational mistakes. And obviously, CJ, that keeps you and team up. I think it's also just in general, like, again, high stakes. And Kirsten, I love you. You're like, you know, you're sitting on the PO for like an hour. I would be sitting on that. I mean, I'm just amazed that you can like that an hour is enough, because it is just nerve wracking, you know, and I really,
one was hard.
And I admire, because you again, and I've seen, I mean, they're also like, this is where you get to kind of the craft of it, where I remember like a couple of years ago, when maybe a year and a half ago, Kirsten, where we're like, we believe that DRAM prices are going to go up. We believe that we are in a lull for DRAM, and we need to back up the truck and buy more DRAM than we need. And, you know, there's a little bit of like, you're kind of making a trade there. You're kind of like day trading DRAM, but that was indisputably,
yeah,
that was.
We could actually make a lot of money off that DRAM right now, actually.
Yeah, that's right. Yeah.
That was actually, that was we actually ended up with almost twice what we needed at the time, just because miscommunication, lack of communication between a distie and the actual manufacturer. They went ahead and shipped an order that we had asked to have canceled.
Oh, that's funny. Yep. I didn't know that.
But yeah,
bank error in your favor.
It ended up in our favor. Yeah, that DRAM. I won't get into like what we bought it for, but it's selling for about $500 each right now. DDR4 64 gigs. So Yeah, that one worked well in our favor. But there's been a lot where it's like, yeah, we should look. We probably have like a week, and then it's like, no, like Steve, you have to sign this PO today. We have to get this supply. We have to lock it down.
Well, I love. Have you ever been, Adam, in the CJ's chain of command for a PO where it's like, okay, Steve has to sign this PO tonight, and the plan is like if Steve is like unavailable, like there's CJ has like a whole like chain
Call
of
tree.
Control. Yeah, exactly.
Call
They're
tree.
like,
we go out of Matrix and straight to the phones.
That's right. And next thing you know, like Al Haig is signing a PO.
That's a great one. I love it.
You know, give the kids something to go.
There we go.
Go ask ChatGPT. ChatGPT knows what I'm talking about. ChatGPT got the reference.
Yeah.
You millennials. You know what I love about that is that Al Haig said that would be the fourth sentence in his obituary. And the New York Times made his quote about that the fourth sentence in his obituary. It was very meta. I really. I'm not explaining Al Haig to you. I'm sorry. There's certain things just got to go Google. So the procurement has been an adventure and is going to be an exciting adventure. Now we've got a lot we need to go do there. As we kind of get into new markets, because people are like, hey, when are you going to sell in Europe? Or, when are you going to, there are like lots of questions like that. Eric, when are we going to sell in Europe?
I'm not sure if Eric's maybe been disconnected, but so basically with selling to Europe, there's more compliance things to go after, both on like the technical, like electromagnetic type safety certifications, and then also some environmentals like REACH and RoHS. And so, the EMC type stuff is, we go back to the lab, the National Recognized Testing Laboratory, which we use Intertech. So we go back to the lab and do a bunch more testing. REACH and RoHS is mostly a bill of materials and procurement exercise to make sure that all the components you're procuring have those certifications, or, for all the custom items that we have, like sheet metal and stuff like that, that they conform to those environmental standards. And so Kirsten has done a ton of work in this space, again, on procurement, part of scale, getting ready to go into new markets, to go, get that data point from all these suppliers on all of these components that we have on the bill of materials. Now, fortunately, most of these are pretty common for REACH and RoHS. I think we found one resistor out of countless that had lead in it, and so we've got that in the queue to get that replaced. But
that was the only one.
Yeah, it's the only one out of
an easy drop-in alternate. Like it's not anything that had to be changed majorly. It was like, oh, they have a lead-free version. Here, just use this.
Oh, okay. I got this question once. I did not know how to answer it about the leaded components. That's interesting. So we only had one. That's amazing. Is that
amazing?
Surprise?
Yeah, and I think it reflects the experience of our engineering team. I think there were a lot of things that they were looking out for, right, when we were putting together the bill of materials. So, but still amazing that there was, one.
I mean,
we were facing far worse. So
I was never going to lick the board to begin with, but it's just helpful to know that if I were to lick the board, it would not be lead that I'd be getting. I
was going to mention one of the things with the REACH that I've learned is that REACH changes every 6 months, so they're always adding new components or reviewing the component list for substances you can't have or can be limited. So, we're going through the exercise to get the REACH and RoHS documentation for every single part that we've got on our bill of materials. And it took several months. And during that time, like there was a new REACH directive that had come out, and it's like, oh, are you kidding me? Like, we really have to go back.
Are we going to have to engineer the fentanyl out of the board? Because that's going to be really...
We might have to, yeah.
That's going to be a challenge. I did drop a link to the chat, by the way. I encountered this over the weekend that I wanted to ask you about, because in terms of like our concerns about regulatory compliance, There was this, admittedly, in the $5 electronic pile at Target, a Bluetooth speaker for $5, which feels like, what corners do you cut there? Apparently, you cut corners around the FCC compliance. So or at least this rating was not tested under the FTC standard, and I wasn't sure. Like, are you allowed to do that? Are you? Maybe we can get into new markets. We can just say like, no, we just didn't do it. But
certainly not the approach we're taking.
That's not the approach. I think it's.
But and then there's the other thing about exporting new markets is there's the trade compliance piece, which we are figuring out. We're not ITAR, so we're not going to have to worry about all of those compliance requirements, but we are going to follow under the Export Administration Regulations EAR due to some of the technology that's embodied in our product. So,
interesting
work to do there. A lot of particularly around networking. A lot of those ICs that we use have export controls on.
Interesting.
Pretty much every QSFP module is export controlled. So, work to do there to get the appropriate licenses, but yeah, fun new things to learn in service of growing the business. So,
well, and then as long as we're on that, just because it is a question that people have asked me for sure, is because I think it's also the kind of the thing that people see is like, wow, the tariffs must be really awful for you, and like they're obviously not great, and in particular because things keep changing. It's really hard when things are changing. I think it's hard when anything is changing. I am like that there are so many other challenges. It's not like they're not like they definitely are a challenge, but I think there are lots of other challenges. And then for lots of the things that we're buying, it's like they often already. I mean, certainly many of the components we're consuming from Taiwan, for example, fall under existing trade agreements. So when that has not been. I guess I should knock on wood when I say this, but it's not been absolutely brutal for us. It's just been kind of yet another thing we've had to go deal with.
Yeah, I think, when this all started with all the uncertainty, Kirsten and I and Eric, got with our suppliers, and it's really just about mapping, right? There's a thing called the Harmonized Tariff Schedule, the HTS code, which is going to dictate that when that thing shows up and gets received and what tariff is applied. And so there was a scramble for data gathering, both on what is the HTS code or what is the HTS for this component, and then what countries is it sourced from? Because sometimes there are country specific interpretations of those HTS codes. But yeah, I think we at least have the data mapped for the top 90% of the bill of materials for cost.
Right.
And I haven't checked Twitter, but that could change, tonight. But at least we know now how things are being processed through.
Well, and the exposure is always kind of it's kind of funny. Like we've got more exposure, I think, to Malaysia than we've got to. Which is like, oh, okay, that's good. Like, let's keep.
Yes, we source globally. I mean, we talk about Sanyo Denki, like those come from the Philippines. We source from all over the place, and there's really not any getting around that in this industry. Even if a supplier wanted to stand up a factory in another country to optimize for tariffs, that's measured in years. And
certainly like these parts start in Taiwan we've got, clearly like totally. the TSMC fabbed parts. So,
right. So it's definitely been a bonus challenge for us to go work through.
A bonus challenge. Yeah.
But hey, we're better for it, I guess.
Well, and I would say, correct me if I'm wrong, but my impression is that the challenges of scale are far greater than these kind of external. The external challenges are challenges. We've got to go knock them down. But they it feels like the challenges of scale have been much, much, much greater.
For sure. Yeah, I think we've got that stuff quantified. And like we talked about earlier at the top, we've been laying the foundation here for a little while, but there's still plenty of work to go execute on to make it a reality. So.
And so I think people are always surprised about how teensy tiny our team. The whole team is, I think maybe we just crossed 80, but we've got all of Oxide is actually quite. So I actually really appreciated it when we announced our Series B. People are like, "You guys have built everything you've built on $89 million." Like, yeah, that's so we've really made things go far. But now that we're kind of in this new era of scale, I know we're really we're scaling across the team, but really focused on operations and the engineering required for manufacturing. Do you want to describe a little bit, CJ, about kind of like?
Yeah, I think we've been very well served with the group of folks that joined us here at Oxide with like a lot of domain expertise and versatility. Folks that really understand all aspects of supply chain, have kind of worked in various functions in supply chain and understanding how all that ties together. And then, we were also very fortunate on the engineering side, on the hardware team, to have kind of supply chain savvy folks who are kind of at the top, really thinking through the implications of the parts we choose. And so I would say those two things are going to remain critical. We want to hire for that domain expertise, but also folks who can be versatile and either go deep on something new, as Kirsten and Eric and I have been doing for the last 4 years, but really bring a core expertise to the table, and then can help wear another hat as needed.
And it should be said that we are using the Oxide hiring process for these roles as well. Which I mean, our hiring process is like it's normal nowhere. So there's no domain in which it's not idiosyncratic. And then I think that there are domains where you're just like, what? Okay. And I mean, Kirsten, I remember vividly where I was when reading your materials when you first applied to Oxide. I mean, this is an unusual hiring process by any standards, but certainly in operations. But CJ, we still ask the same questions, same questionnaire. We look for a different work sample, though. Can you describe a little bit kind of what goes into the work sample for some of these roles?
Yeah, I think as we grow the team, we're looking to hire, more focused roles a little bit. And so what's actually been challenging is like, what questions do we want to ask in like the work sample or the analysis sample that's going to help us identify candidates that have what we're looking for. And you have to really be thoughtful there in terms of what kind of work sample or whatever that you ask for, because we're getting all these applicants and we're reviewing them, and to sort of triage the candidate pool, those questions for the role specifically, the ones that are specific to that role, are critical to get right in terms of asking the right question in the first place. And then, you have the standout applicants that really just nail it, which we've been very fortunate to have a lot of good candidates applying. So,
and I would say to anyone applying to Oxide, just because we are expanding a bunch and spending a lot of time reviewing materials, for all of our roles, definitely in operations and engineering, but across the company, please read the job description very carefully, and please read the materials very carefully. CJ, I got to say, one of the things I really love about this latest crop of materials is on the prompts, you really are very explicit about what we're looking for. Kind of like what our rubric is as we are what we're reading for, because we're not trying to we're not trying to play gotcha. We're trying to actually get terrific people to explain what they've done and why they want to work for Oxide.
Yeah, I hope so. I think it's all, you can pretty much take those questions and track back to something that we're working very specifically on right now, and in a hurry. But yeah, there was a question in the chat about folks whose work is largely private or proprietary. We encounter that quite a bit. And what we've found is that most candidates are able to describe the work adequately, even if they don't get into the specifics of like company names or dollar values or what have you. You may not be able to share the planning workbook you used to plan, whatever supply chain, but describing it in a thoughtful way and adding appropriate context. We've got folks that have submitted great materials, even though some of their prior work was proprietary.
One of the just more broadly things that we're looking for is we'd be silly to say that there's anyone that fits every single box or rubric that you were talking about there, Bryan. one of the things that we're looking at, especially in our company, is where a solution doesn't exist. What do you do where there's not a system or a thing that tells you what to do? A lot of, like CJ has worked at, Apple and Pearson at Lenovo, and at some of those larger companies, you have the benefit of a system or a process that exists. We have the benefit of working with companies that have processes, but broadly, they look to us to tell us how to do things, how to build. So,
Yeah.
I think what's really important is being able to have the humility to ask questions, but where something doesn't exist, you look to your left and you look to your right and say, if it doesn't exist, you need to build it. Whether it's like a test fixture, for example, or a test itself on the software side, or whether it's documentation or something to tell them how to build it the best, so we can build that quality into our product at an early stage as possible. So I think that's what we're looking for. Initially, when we looked at this, one of our roles that we're advertising for, the manufacturing project manager role, initially was aligned a little bit more closely to like a manufacturing engineer. And while that's a very important skill set and something that is important to the job, it is not the only thing that you need that person to be able to tackle. I think what's really important is being able to understand that there's, like we've talked about, the person in this role would have to be, like we use the term athlete quite a bit, but obviously have a strong manufacturing engineer skill set, but also someone that can reach out to and have the ability to speak to how something is scheduled on the floor. Help to provide some insight on our manufacturing test fixtures, work with our engineering team, work with our software team. So there's not one person that is able to do that maybe out of the box, but someone that's willing to recognize where those gaps are and pull the right team together so we can be successful.
And yeah, and this is a challenge because I think, as you say, Eric, for a lot of folks that are engaged in manufacturing or supply chain management, procurement at a large company, you're part of this large system that doesn't change very much. And while that experience is very valuable, we really need folks that can be really. I mean, CJ, you spoke to the need for versatility and just being able to be. I mean, I just think the number of times we've been just creative about finding solutions to problems. And really, we also, you all do a very good job of not really taking no for an answer in a very polite way of like, okay, like, let me understand, Kirsten, just what you're describing about, like with the Marauder problem, like, okay, so you say I can't have this for 19 weeks. Let's understand why. Let's get into there. Let's work kind of collaboratively, figure out how we can solve this problem, work collaboratively with our contract manufacturer, solve this problem. I think, Eric, one thing for that role in particular, and I think we are broadly a remote company, or we are a remote company. There are a handful of roles where we don't need you to be on site in Emeryville, but on site actually at our contract manufacturer is extremely helpful. So in this case, it's lovely Rochester, Minnesota. But I think as we expand, we can probably expect a couple more of those. So. We'll be fortunately, and CJ, I'm amazed at how much we're able to. I think there is a bit of a myth, I think, that you can't do hard tech as a remote company. I think we've proved that you can.
Here we are.
Here we are. Exactly. That's right. We lived, or we're alive anyway. But there are some roles that do actually need to be boots on ground. And Eric, we've really appreciated you being your physical presence. You are not based out of Rochester. You are a drive away from Rochester, but your physical presence has been absolutely clutch over and over and over again to help us navigate problems by actually being there on the ground with folks.
Yeah, I think that's been a delicate balance. As we, I think we've been in a low rate production, but we've been in some state of a new product introduction, NPI, for roughly 2 to 4 years, depending on where you draw that line. And I think it's really important to understand, one is building relationships at the manufacturer, but also we don't have everything built real time. A lot of the times we have to deploy something and then work through that process with our team. So I am a little bit more local, but we also have our Wisconsin contingent, which has been a huge help as we've tried to deploy. So if we have short notice things that pop up where we need to either do some troubleshooting or work through a process, they're there and available. And it's building that rapport. I mean, we're going back to some of the conversations I think we had maybe 2 or 3 years ago when we last had our first customer ship. I think that's been absolutely invaluable. So there's, in a world of remote work, sometimes you just can't replace, being on site and just seeing something happen real time and answering those questions, especially when you're trying to move fast. So even though we've been in a state of low rate production, we've still been throwing a lot at our contract manufacturer. And so being there to work through those problems real time is extremely helpful. So then you can bring back those issues to our engineering team, and we can improve on that feedback loop much better than we could, over email or even a video call, because it's hard to, bring your computer out and, hang it vertically over a sled and say, hey, here's the problem we're having, or here are the issues we're having. You just need to touch and feel and do that needful work.
Or over an ocean, Eric. I mean, I think this is like one of there are many reasons why we have a domestic manufacturer, but first among them, honestly, is the speed of that feedback loop and us being able to be on site and being able to just quickly resolve problems. And Kirsten, I remember vividly when we had a really acute problem with a manufacturer that was an ocean away, and it was brutal in all the ways that these things are like kind of comically brutal, where you are taking these long laps of like you can only kind of have one conversation a day because of the time zone overlap, and it was just it's tough. There's a lot to be said to just being that time zone locality. But this has been terrific. I think that we have got we're and all of you. I know CJ, you were praising the team, but all of you have done such an extraordinary job. I think the collaboration among the team has been essential for this. And I think the fact that, people have felt that they can always go solve whatever problem we have in front of us, right? People don't need to worry about like, well, okay, our job collectively is to go make this whole thing fly. And it's been really exciting to see that we do not get siloed, and to see that kind of cross-team collaboration. But then also, Kirsten, the thing you were mentioning about the relationships with our suppliers and really treating those as real partnerships has been huge. You dropped RFD 68 into the chat, but that has just been that's been really important for us, and really grateful for those suppliers who have gone to bat for us. And it's great that we can actually make good on their belief in weird old Oxide, that we can actually pull this thing off. Well, again, congratulations, everyone. Really exciting stuff. A lot of excitement in the future. CJ, a lot of problems ahead for sure. A lot of exciting problems ahead.
Good problems to solve.
Good problems to solve. Yeah, new problems, as Aaron says. I can't wait to see the new problems. But we've learned a lot, and we all of this. The timing is perfect. Like we are flexing this thing up at exactly the right moment. We're ready for it. So ready for those new challenges. Thank you, everyone. I think I'm gonna set it. I'm gonna put out a teaser, Adam. We just had the whole company out last week. It was amazing. The Ballers game was great. Wasn't that fun?
Super fun. Yeah. And they're in the next round.
They're in the next round. I was actually visiting my older guy in college with my daughter, and we were listening to it on the radio, and just it was the call as they won 1-0. I don't know if you saw that.
No, I didn't see that.
No, that was a 1-0 victory with a Chabot product on the bump. So nice. It was really, really fun. Gabe Tanner, nice going, fired up, pitched 8, very nice. So we got my plug one is for the Ballers Championship is coming up. Tickets are going fast Friday night for will be Game 3 of the championship series. But the thing I wanted to tease, Adam, was not a baseball game. Although I guess you wouldn't know it from what I just did. But we saw some great talks at OxCon. In particular, our colleague Dave Pacheco gave an absolute banger of a talk on what on the journey of software update. We're going to have to we got to have him on. We got to get that thing out there somehow, don't you think? And
sure. Have you told Dave that?
I mean,
or is this you telling Dave?
Dave's a listener to the podcast, right? I mean, I think we've established that. Well, this is the way to find out. No, of course, I definitely told Dave that. But I've told Dave some of that anyway. I feel I've told Dave much of that. I've told Dave much of that, and what I didn't tell, he could reasonably infer, and that he didn't reasonably infer, he now knows. So there we go. Yeah, it's all out there now. Good.
I will hustle on and get this recording to Dave as soon as possible.
Yeah, and I'm loud and proud of the TPS 546A24B. I'm out there. I'm holding hands.
Good.
With my favorite regulator. I'm just like I'm loud and proud out here, man.
Good.
Good stuff. All right. Well, so that'll be added a future podcast episode. But looking forward to that.
Should be fun.
And go Ballers.
Yeah, go Ballers.
All right. Thanks, everybody. See you next time.